Hello everyone. In last video we discussed the topic phase change of matter, specific heat capacity and the specific latent heat. As I had said, we are going to solve the questions. In the next video I have created one question for you and I'm going to solve this question for you. Please watch this video carefully and try to solve with me so that you develop a good understanding of specific heat capacity and the latent heat. So here is our question. Calculate the heat required to convert 3 kg of ice at minus 12 degrees Celsius kept in calorimeter to steam at 100 degrees Celsius. The specific heat capacity of ice is 2100 joule per kg Kelvin. Specific heat capacity of water is 4186 joule per kg Kelvin, and latent heat of fusion is 3.35 into 10 power 5 joule per kg. Latent heat of vaporization is also given, which is 2.25 into 10 power 6 joule per kg. You can pause the video and read the whole question and take a note of this question so that you can solve with me. And I would suggest, before you go further, please pause the video, solve the question on your own. Try to solve 1 or 2 times. If you are not getting the answer on your own, then watch the full video for the solution. Let's get started. So as you can see in the question, there are ice cubes, or you can say there is just one ice cube, and that ice cube is at minus 12 degrees Celsius, very much like my explanation which I had used in the last video. And this minus 12 degrees Celsius ice is taken to the boiling point, which is 100 degrees Celsius, and at this boiling point it's converting into steam, right? So if you keep increasing the temperature of this ice will convert into liquid somewhere above 0 degrees Celsius and above 100 degree or when the liquid reaches to 100 degrees Celsius, it will start converting into gas, right? So 3 stages are there. One is increasing the temperature of ice, then melting the ice, then increasing the temperature of liquid, and now the liquid is converting into the gas. So let's start with understanding how much heat is required, first of all, to bring the ice from minus 12 degrees Celsius to 0 degrees Celsius, right? Because here we will use the concept of specific heat capacity, and when ice will reach to 0 degrees Celsius, then the phase change will start, not before that. So I can find the heat required to increase the temperature of minus 12 degrees Celsius of ice by using the concept of specific heat capacity, which is Q is equal to ms delta T. And delta T you can see from here only. How much is the delta T? 12 degrees Celsius is the rise in temperature. So I can write Q is equal to mass is 3 into specific heat capacity is given to us, specific heat capacity of ice, which is 2100 joule per kg Kelvin, into change in temperature is 12, right? So if you see this, you can write the specific heat capacity Q is equal to 12 3s are 36 into 2100. If you will do the calculation, you will get 75,600 joule. Why I'm writing joule? Because the unit of heat is joule. So this is the heat required in the first stage, it means just increasing the temperature of ice. Now second question is, how much heat is required to melt the ice, right? Because now here the phase change will take place. So what we can do here, we can write the formula of specific latent heat for melting. So Q is equal to L into M, or sometimes you write M into L. Let me make some space. I will write here. So Q is equal to, as I have written, Lm. Let's substitute the value. The specific latent heat of melting must be given to us, which is equal to specific latent heat of fusion, and that is 3.35 into 10 power 5 joule per kg into the mass, which is 3 kg. So if you will do the calculation, you will find that specific latent heat of melting is I will write 10 power 5 first, then I can write 3 5s are 15 and 3 3s are 9, plus 1 10, and 3 3s are 9 plus 1 10. So we will get something like this, and two decimals, so 10.05 into 10 power 5, which can be written as 1.005 into 10 power 6 joule, right? So this is the heat required, but as we will need later on for the addition, because this one is only in the form of just numbers, so I can write it like Q is equal to 1005 and two more zeros, I think. Not two more zeros, because here 5, so one more zero, yeah, one more zero, and that becomes the heat required. Now the third stage I will write here, because I want to utilize the space. So the third part is how much heat will be required to raise the temperature of 0 degrees Celsius liquid, because now once the ice melts completely, the temperature of initial temperature of liquid would be 0 degrees Celsius. Now as you keep adding the heat, the temperature of this liquid starts increasing. So in that case, it will go from 0 degrees Celsius to 100 degrees Celsius. So again, as there is change in temperature, we will use the concept of specific latent, specific. As there is change in temperature, we will use the concept of specific heat capacity. Let's go on the next slide, and then we will continue with the question. Now our third stage is the change in temperature of liquid. So change in temperature of liquid, which is at 0 degrees Celsius, and we are bringing it to 100 degrees Celsius. So in that case, because there is change in temperature, you will use the concept of Q is equal to ms delta T. And as we have done earlier, same thing we will do. We will do Q is equal to mass, which is 3 kg, given to us already, and as you have seen on the last slide, the specific heat capacity of liquid is given to us, and the specific heat capacity of liquid, which is water, is 4186 joule per kg Kelvin. Into change in temperature, you know how much is that? 100, right? Because 0 to 100 degrees Celsius. So change in temperature is 100. Now if you will multiply this, you will get Q is equal to, after multiplication, how much it comes? There are two zeros, so I will add two zeros here, and I will write here 1 2 5 5 8. You can use the calculator if you want, or you can just simply use the pen and paper. Now the next stage is the latent heat of vaporization. Now the energy will require to convert the liquid to gas at constant temperature. So at 100 degrees Celsius, liquid is turning into gas, right? So because the temperature remains constant, we are going to use concept of latent heat. So Q is equal to L into M, as I have done in the last part as well. So we will write here Q is equal to L, we need to know in this case, and latent heat of vaporization is 2.256 into 10 power 6 joule per kg into mass 3. So when we will multiply this, we will get that the heat required to convert 3 kg of liquid into the gas would be how much? Let's do the calculation. So I will write here 10 power 6 in advance, and you will get something like how much? 8 and 3 5s are 15 plus 16 and 3 2s are 6 7 and 3 2s are 6 6 7 6 8 into 10 power 6, and here decimal, let's add decimal. So finally I can write here the heat required in the fourth stage. I'm just writing for your reference, this is the fourth stage, that is 67680, right? Not 00 because 3 decimal places here, so one more 0, joule. So this is our Q. Now the total heat required to take the minus 12 degrees Celsius of ice to 100 degrees Celsius of gas, which is vapor, is equal to, let's add all the Q1, Q2, Q3. So it will be total is equal to, how much was that, if we can recall that? So that was in the first case 75600, and in the next case it was 100 and 500 or triple zero, and plus how much is that in the third case? 1255, it's here on the screen, 00, plus in the fourth stage it's 6768000. If you will add this, then total would be how much? Total would be, you can use the calculator or something, you will get 9104 and 400 joule. This is the total heat. So total heat required is 9104,400 joule. So I hope you understood how we can solve the equations related to specific heat capacity and latent heat capacity together. I would suggest that you solve this question on your own once again, and if you get stuck, watch the video. See you. Happy learning.